Hello, my name is Anna, and this is my Experiment 2 report for Physics 2. The purpose of this experiment was to examine the relationship between distance and the strength of the magnetic field of a bar magnet. This experiment was also used to simulate the magnetic field using a computational model and then compare the simulated magnetic field to the one found in the physical experiment. The physics principles used in this experiment are the general form of the Biot-Savart law, which is used to calculate the magnetic field in the GLOW-Script model, and then also the dipole on-axis form of the law, which is used in conjunction with the magnetic field of the bar equation to find the magnetic dipole moment and distance dependence relation. The superposition concept is also important in this experiment to ensure the Earth's magnetic field is taken into account, and the linearization equation shown here is used to find n. As a preview of my results, my n value is negative 3.344, and magnetic dipole moment value was 2.673. In addition, the main assumption in this experiment is that there are no magnetic fields affecting the results besides Earth and the bar magnet. The possible sources of error include other magnetic fields interfering with the magnet, like a TV, for example, as well as potential inaccuracies from the app itself and human measuring error. I identified the system as the magnometer and the surroundings as the bar magnet. The initial conditions are my phone with the magnometer downloaded, a bar magnet from Howie, tape to measure, the magnometer facing north, and the bar magnet perpendicular to the phone. I started by downloading the magnometer app onto my phone. I then placed my phone on my desk and rotated it until the app showed 0. Then I aligned my tape along the bottom of the phone east to west and oriented my phone along different distances to get values at a 45-degree angle. I put all of this data into the Excel file. For the on-axis data, the magnometer needed to create a magnetic field of Bx equals 20 microtesla, 70 microtesla, 120 microtesla, 170 microtesla, and 220 microtesla. For measuring off-axis, I found a distance, so d perpendicular had a magnitude of 100 microtesla, then recorded the y value of this distance, and then moved my phone up a distance of d perpendicular. I then determined the vector magnetic field at that location. I observed that when the magnometer is far away from the magnet, it measures a near zero magnetic field in the x direction, and that as the magnometer moves closer to the magnet, the measured x component of the magnetic field increases. The Excel sheet shows all of my measurements and is used to get n and k. From the graph on Excel, the slope, which gives n, is negative 3.344. Using the y-intercept of the graph, which is negative 14.682, k becomes 4.204 e to the negative 07 from the linearization equation. Solving for the magnetic dipole moment using the magnetic field of a dipole on-axis equation and setting it equal to the magnetic field of a bar equation, I got that mu is 2.673 amps meters squared. The first thing to edit was the magnetic moment line, which I changed to match my mu. I then created the magnetic field function using the general form of the Biot-Savart law. From there, I created the observation locations where the arrows would be placed. I then created the on-axis magnetic field arrows and the perpendicular axis arrows and changed the d-perp to match my value from Excel. Finally, I created an arrow for the magnetic field at a 45-degree angle from the axis. The similarities and differences between the data and model can be highlighted in the B net at the 45-degree angle value, 2.02026 e to the negative 5. This value is similar to the Excel sheet value of 3 e to the negative 5 as they are the same order, but is likely off due to human error. To reiterate my values from the introduction, the smaller the distance, the stronger the magnetic field. My n value is negative 3.344 and my magnetic dipole moment was 2.673. The first what-if question gives that the values calculated, the k, n, and mu, would be inaccurate and the magnetic field at x would also be different since it would not be 0 anymore. The second gives that the magnetic field of the two magnets would be greater than the field for a single magnet due to superposition, but the results would be similar in terms of the physics concepts demonstrated. Thank you for watching.